Welcome back, Padres. Hope you guys had a good spring break. We're going to finish our last unit on astrophysics. So hopefully you guys will enjoy this. We're going to break this up into several parts, and let's start with the first one. The first part is going to be on celestial objects. And something else I wanted to mention, I do highly recommend you take notes, write this stuff down just like you were in class. Um, I think it's important. I think the process of writing with your hands on paper, it helps you kind of process and submit the information. So even though we're not in class, I do highly recommend you take the notes to kind of process this information. Let's move on. We're going to talk about just some basic celestial objects, and then we're going to talk next week about cosmology and the birth of the universe and where's the universe going. We're going to talk about stars, get some details about some star stuff in the following weeks, and then planets. We're going to start with celestial objects. We're going to start about what a planet is. A planet needs to orbit a star, but it also has to have three additional criteria. So actually orbiting a star, I guess it's its own criteria, but beyond that, there are three other criteria that need to happen. First, it needs to be massive enough to be rounded by its own gravity. So if an object doesn't have a lot of gravity, it might be like an elongated shape, but gravity will force an object to be round. So if there's enough gravity to make an object round, that's the first criteria for being a planet. Second criteria, it needs to be not massive enough to cause fusion. So if gravity is strong enough or it could compress the atoms hard enough, it will cause hydrogen and hydrogen to bond to form helium. And when that happens, we get fusion, releases a lot of energy. This is the process that stars undergo. So a planet can't be massive enough to actually fuse that hydrogen and fuse other elements. So massive enough to be round, but not too massive enough to cause fusion. And the third one, it has to have cleared its neighboring region of debris and other objects. So if you have the star going around, it needs to be the planet needs to be massive enough so that it swept the area clean of debris. So if there's still debris in the area, that means the planet hasn't. It's actually not a planet because it hasn't swept the area clean. It doesn't have a clear path to travel. And of course, we know examples of planets: Earth, Mars, Saturn, etc. And here's a lovely picture of a planet. A moon. A moon is an object orbiting a planet. It doesn't have the strict criteria that a planet has orbiting a star, but a moon can just be orbiting a planet. Some planets have no moons, like Mercury. Some planets have many moons, like Jupiter has 79, and that's not by any means an upward limit. Planets can have more moons than 79. 79 is the most in our solar system. So Jupiter has the most of the planets orbiting our sun. So examples of names: the Moon. Titan is a large planet that orbits Saturn. Phobos is a planet that orbits Mars. And there's a picture of a moon. A star. A star is a self-luminous, that means it shines, gaseous object. So it is made of great mass, produces an energy by means of nuclear fusion. So like I mentioned before, it needs to be massive enough so that it's fusing atoms together to create that energy, that burst of heat and energy. So some examples are the Sun, Alpha Centauri, Rigel, and we're going to go into more detail later about star lifetime and how stars are formed and what happens with stars. Here's some pictures of some stars in space. A constellation is a group of stars. It forms an apparent shape of an object. The object is usually a mythological creature. This is just because way back when people were looking at stars, that was all you could really do at night. Stars were a big centerpiece. This was before, TV, before internet, before radio. People would just go outside and look at the stars a lot. And so they came up with stories about the stars. So these stories are the constellations. There are 88 constellations in our sky. And unfortunately, we're unable to see most of them here in the Carmel, Monterey area because of clouds, a lot of fog clouds. And it's important to know that stars are not clustered together. So if you take the stars in the Big Dipper, those stars in the Big Dipper are not bound together. They're not really even necessarily close to one another. It appears that way from our point of view. So one star, if the Earth is over here, one star might be here, one star might be way over here, another star might be way over here, but it's just from our view is how we see them in that pattern. So the stars in the constellations are not bound together. They're not tied together by any means. It just looks like they're in that shape. If you were on another planet far away, on the other side of the galaxy, the stars would look entirely different. Because if you're here and you see from this perspective, or if you're over here and you're seeing back from this perspective, the stars are completely different. So once again, it's not like this constellation is an object of, or a grouping of stars that are kind of together, and we're just seeing those. So they would look the same from different points of view. They're actually just stars that are just randomly, not randomly, placed around, and so they look that way. It's the apparent shape. And here's the Orion constellation, which we can see here in the northern hemisphere. Nebula. The reason I put the E here is plural is nebulae, singular is nebula. So if you have a bunch of nebula, it is a nebulae. It is a giant cloud of gas and dust in space. Here is the Carina Nebula, the Crab Nebula, and of course the Marvell Nebula. And gravity is kind of pulling these gases together, but it's just gas right now, just gas and dust floating in space. The nebula. Comet is up next. A comet is a small icy object. It orbits a star and it releases gas and dust, which produces a tail when it's close to the star. The orbits are very elliptical, and some notable comets. Halley's Comet has an orbit around our sun every 75 years. It orbits. Hale-Bopp, it orbits every 2,500 years. The reason I put Hale-Bopp on there is Hale-Bopp was a comet that came around in the 1990s, and it was well studied, and it was very visible from Earth. You could see it. It was bright in the sky. So here's a real picture of a comet. It kind of just looks blurry. It's probably taken with the telescope, but even with your naked eye, it just kind of it was kind of like a blur in the sky. And like I said, it's a very elliptical orbit, usually. And the solar winds, the sun is actually throwing off energy, throwing off radiation. And when that radiation hits the comet, it's melting the comet, it's throwing the tail in the opposite direction. So you'll notice that the tail is always going away from the sun. So the tail is not going, backwards. Like if you're flying, your cape, if you had a cape, your cape would be behind you. it's going away from the sun because that's where it's getting the push. The wind is coming from the sun, the solar wind. All right. Here's a video on comets. Um, I suggest that you watch it. I'm not going to play it because if I do, you're not going to be able to hear the sound in it. So but please click on the notes, take a watch of this video. A minor planet. A minor planet is an object that orbits a star. It's not a planet or a comet. So so far we've talked about two things orbiting stars. We said planets orbit stars, and they have those three criteria. And we have comets orbiting stars, which are clumps of ice. I didn't mention before, comets can hit the Earth. Um, we think a comet killed the dinosaurs. Comets hit other planets. Comets hit the sun. So comets are flying around out there, and they do strike objects. It doesn't happen super often, mostly because in space there is a lot of space, and so they usually miss things. There are two main types of minor planets, though. So a minor planet, once again, it's not a planet, it's not a comet, it's something else. It's either a dwarf planet or it's an asteroid. So let's talk about those two. Dwarf planets. It's an object orbiting a star. It fits the first two criteria of being a planet. It's round, and it doesn't cause fusion. So it has those two criteria. But it does not fit the third criteria. So there are things in its orbit still. And so dwarf planets are large, but their orbital area is still cluttered with other debris, space debris. And this is Pluto. So Pluto is considered a dwarf planet. This is why Pluto got demoted from planet status to dwarf planet status, is because of not having a cleared out orbit. Ceres is a large planet in the asteroid belt located between Mars and Jupiter. And some people call it an asteroid, but really it's been recently classified as a dwarf planet because it's large and round and so here's an example or a picture, actual picture of Pluto, and here's an actual picture of Ceres. So you can take a look at those two. And you can just see by all the stripes on it, it has not cleared its path. Things are still hitting it. Here's a good video talking about the 5 dwarf planets. So once again, take a look at this. I'm not going to play it here. All right, asteroids are the other type of minor planet. Asteroids are objects that orbit the sun. They're not planets. They're not comets. They're smaller than dwarf planets. They reside in the asteroid belt located between Mars and Jupiter. So here's a picture. You can see Mars is here. Jupiter is over here. And there's just a bunch of asteroids there. They're smaller than dwarf planets. Usually they're not round. They're not completely round. Like you can see, here's an asteroid, and the gravity is not strong enough to round it out when it was being formed. So it's more of an oblong rock shape. Once again, a couple more videos. Here's a video talking about showing the different sizes of asteroids compared to cities. Some of them are small, some of them are large. Pretty short video. And this video has Bill and I talking about, could we stop an asteroid from hitting the Earth? Because once again, just like comets can hit the Earth, asteroids also hit the Earth. All right, meteoroid, meteor and meteorite. These are all small bits of dust or rocks. They range in size between a grain of sand and a microwave oven. And whether it's a meteoroid, a meteor, or a meteorite depends on where we find it. If it's in space, we call this little bit of grain of sand size dust or rock, we call it a meteoroid. However, if it enters the atmosphere and it burns up, is a meteor. Sorry, I said that again. A meteoroid that enters the atmosphere and burns up due to friction is a meteor. So if we have this little bit of dust or maybe a baseball-sized rock, it's coming into the Earth, it's hitting all that atmosphere, lots of friction, it's going to heat up. Usually they burn up in the atmosphere. They just burn up into nothing. And that burn up into nothing is a shooting star. Sometimes they will not completely burn up. They will strike the surface. When that happens, they are called a meteorite. So a meteorite is basically a meteoroid that goes into the atmosphere, turns into a meteor, hits the ground as a meteorite. Another video. This one's talking about the differences between a comet, a meteor, or an asteroid. So take a look at that. And we're getting to the end. Galaxy. A galaxy is a huge collection of gas, dust, and billions of stars, and all the planets in the solar systems, and they're all held together by gravity. So, galaxy is a large collection of stars, and the planets around the stars, and the comets around those stars, and all that together. There are four main types of galaxies. We have spiral galaxies. They're flat spinning disks with arms. Barred spiral galaxies. They're the same as spiral galaxies, but they have a bar at its core in our pictures that I'll show you in a second. Elliptical galaxies are round or elongated. They have no central core. And irregular galaxies. So spiral galaxies look kind of like this. They have these spiral arms. The center is this big bulge disk that's brighter than everything else. We do not know what's in the center. But all these bright points are stars. We have billions and billions of stars circling around this massive object in the middle. The barred spiral galaxy, it's basically the same thing. It has it's an elongated shape. It's like a bar here in the center instead of being round. Elliptical galaxies don't have arms, so they're just round galaxies with no central core. And irregular galaxies are just kind of like the oddball. So our galaxy, the Milky Way, stars we can see at night. So if you look up, see a star, that star is part of our galaxy, the Milky Way. So our galaxy, actually, our galaxy, the Milky Way, looks kind of like this, but it has a bar in the middle. So it has many arms. It doesn't have just two arms. It has many arms spiraling, but it's a bar. But all the stars we can see at night are in this group of stars that are circling around this massive object in the middle. Like I said, our galaxy, the Milky Way, is a barred spiral galaxy. We estimate that it contains 250 billion stars. The radius of the Milky Way galaxy is 52,850 light years. And recall that light travels very, very, very fast. And 1 light year is the distance that light can travel in a year. So a light year is a distance, it's not a time. So even though it says light years, it is not a time, it's a length. And it's the length light can travel in 1 year. So it would take 52,000 years for light to travel from the middle of the galaxy to the edge. And remember how fast light travels, that it's a very far, far. So here's a picture of what we guess the Milky Way galaxy is. We have not been outside of our galaxy, so this is not a real photo of the Milky Way because we can't get outside to look in at it. But judging by what we know the Milky Way looks like, this is a galaxy that looks similar to ours. and we would be about here on one of these spiral arms that are circling around. And here's a video talking about galaxies. This is a real image from a Hubble telescope, and each of these little circles is a galaxy, and each of these has billions of stars in it circling around. And finally is the universe. The universe contains everything. The universe is all stars, all galaxies, all space, all time, everything is the universe. Okay. And we estimate that it contains 2 trillion galaxies. So it has 2 trillion of these. So that's just, it's a huge, huge number. So just this massive amount of space with 2 trillion of these, and each of these has billions of stars around it. And that's as far as we're going. So that's the end of part 1. There are going to be some 20 questions about the notes here. They are going to be due Friday at midnight. Please make sure you have them submitted to Moodle by that time. And hope you have a great week, Padres. Please, one more thing. Please stop by either sign up for office hours if you need help with anything, if something doesn't make sense, or stop by the live Zoom sessions. And of course, you can always email me anytime and I'll get back to you. And now, have a great day, Padres.